Hello everyone, welcome to Mentor Buddy. This is your mentor Akhil. Today we are going to understand or solve the question which is based on the logic of divisibility. Now, first coming directly to the question says 4 to the power 61 plus 4 to the power 62 plus 4 to the power 63 plus 4 to the power 64 is divisible by among the listed option. Which one? And the listed options are like 3, 11, 13 and 17. So in order to solve these kind of question, we need to understand the two logics which is based on divisibility. That first logic is of negative remainder. How we are going to calculate the negative remainders. And second logic which we need to understand, that the nature of the remainders. Nature of the remainders also need to be understood in order to solve these kind of questions. Now, understanding the two logics separately. So first let's understand the logic of negative remainder. What is negative remainder? How it is going to be helpful? For example, let's say I said I have taken one number 25 and I need to divide the number 25 by the number 3, and I need to see what is going to be the remainder. So we know it is quite simple. If we'll divide 25 by 3, the positive remainder will be plus 1. 3 8 times will be 24, remainder will be plus 1. So plus 1 is going to be the least positive remainder, or the remainder can also be written as like minus 2. So minus 2 is going to be the greatest negative remainder. Now how we are getting it? Let's say for example I need to divide it. So I'll divide it very simply. 25 need to divide it by 3. So I know 3 8 times will be 24. 25 minus 24 will be plus 1. So plus 1 is that least positive remainder. The same thing can also be sorted as, if we need to divide 25 by 3, write this like 3 9 times 27. So 25 minus 27 will be equals to minus 2. So in that case, minus 2 is going to be the first negative remainder. So this is the logic of getting the positive remainder and negative remainder. In most of the cases, positive remainder and negative remainder are, the negative remainder plays the important role in order to solve the question. For example, the question says what will be the remainder when 17 into 18 is divided by 25. Now if we divide 17 by 25, the positive remainder will be 17 only, and if we divide 18 by 24, again the positive remainder is going to be 18 only. So now let's solve this expression by the way which we used to apply in order to solve these kind of questions. So we know 17 into 18 will be equals to 306. Now 306 need to be divided by 25. So this is 306 and we need to divide by 25. So 25 1 times will be 25, remainder will be 5, and keeping 6 here, the 25 2 times will be 50. 56 minus 50, that will be equals to 6. So in this case the remainder is going to be 6. But see, in this case we need to multiply both 17 and 18, then we need to solve it. Now applying the logic of negative remainder. So according to negative remainder, if from 25 the positive remainder is 18, the negative remainder is going to be minus 8. So as we can see, we need to move from positive remainder to negative remainder, move at the step of divisor in the backward direction. The divisor was 3, so from 1, if I'm moving at the step of 3 in backward direction, I'll move at 25. Similarly, from 17, if I'll move at 25 in the backward direction, because 25 was the divisor, so we'll reach at minus 8. Similarly, from 18, if divided by 25, the positive remainder 18, the negative remainder is going to be minus 7. Again need to be divided by 25. Now solving this further, minus 7 into minus 8 will be equals to 56 divided by 25, and we simply know that when 56 divided by 25, the positive remainder is going to be 6. That's the correct answer. So I believe rather than multiplying 18 into 18 dividing by 25 is difficult, then multiplying -8 and -7, then dividing it by 25. So this is the logic where the negative remainder plays the important role. Now coming to understand one another logic of the remainders. Now for the next concept of the remainders, we need to understand, let's understand it with the help of one simple question. Let's say I have taken one simple number 40 and I have to divide the number by 7. So when 40 divided by 7, and I have taken one another number that is 20 and I'm dividing it with the same constant that is 7. So now when 40 is divided by 7, the positive remainder will be +5, and when 20 divided by 7, the positive remainder is going to be 6. So what I have done over here, that I have taken two different numbers, that is 40 and 20, and had individually divided them by the number 7. I got the remainder to be as 5 and 6. Now what I am doing, I'm going to add the two numbers, the 40 and 20, the two numbers. The summation will be 40 plus 20 will be equals to 60, and then dividing the number 60 by 7, 8 times 56, remainder will be equals to 4. So I have added the two numbers divided by 7, remainder is 4. Now what I am going to do, I am going to add the remainders of the same two numbers. So 5 plus 6 will be equals to 11, and when it is divided by 7, remainder is again going to be 4. So here in this case we observed one simple thing, that whenever the numbers added and divided by the constant, remainder is same, to that remainder whose individual remainders divided by 7, and the remainder is going to be again very same. So in this case we can declare that the remainders are additive in nature. Remainders are additive in nature. So this is the first nature of the remainders. Now let's say I'm taking one another case. Let's say the numbers are same. 40 divided by 7, remainder is 5, and when 20 divided by 7, remainder is 6. So now what I'm going to do, I'm going to subtract the two numbers. So 40 minus 20 will be equals to 20, and I'm dividing it by 7, remainder will be equals to 6. Obviously 7 2 times will be 14, remainder will be equals to 6. So now I have subtracted the two numbers. Now to get the nature, I'm going to subtract the remainders of the same two numbers. So from 40 I have subtracted 20. So similarly from 5 I'm going to subtract 6. So 5 minus 6 will be equals to -1 divided by 7. Again coming back to the logic of negative remainder, from 7, if the first negative remainder is -1, then definitely the first positive remainder will be 7 steps ahead, that will be equals to again 6. So again I realized one simple thing, the remainder is again coming out to be same. So that declares that remainders are also subtractive in nature. So we can see remainders are additive and they are also subtractive in nature. Coming to one another property, let's say 40 divided by 7, remainder was 5, and 20 divided by 7, the remainder was 6. So first case I have added the two numbers and their remainders. Second case I had subtracted the two numbers and their remainders. The third case I'm going to multiply the two numbers. So 40 into 20 will be equals to 800. So now when 800 divided by 7, 7 1 times 7, 1 here come, 7 1 times 7, 3 remainder will be there, 30, 7 4 times 28, remainder will be 2. So understand one simple thing, when you're going to divide 800 by 7, the remainder will be 2. So now I'm going to multiply the two remainders. So 5 into 6 will be equals to 30, and again the number 30 divided by 7, remainder will be equals to 2. So in this case we can see the again remainders are coming out to be same. So the remainders are also multiplicative in nature. So we can see remainders are additive, subtractive and multiplicative in nature. These are three important properties which need to be remembered in order to solve the most of the questions of the remainders. So coming directly to the question now. or let's understand one question which is based on the nature of the remainder. So let's say I'm framing one simple question, that is, what will be the remainder when 1421 into 1423 into 1425 is divided by the number 12. So what will be the remainder when this expression, that is 1421 into 1423 into 1425 divided by 12? So if we'll proceed with the traditional approach, that we have to multiply the three numbers and then we have to divide it with the number 12, in that case it is going to be a long time consuming thing, right? Now what I'm going to do, I'm just going to divide 1421 by 12. So let's divide 1421 by 12. So 12 one times will be 12, 2 coming to 12 one times will be again 12, that will be 1 0 and 1 12, 8 times will be 96, so remainder will be plus 1. So when 1421 is divided by 12, the positive remainder will be 5 into. Now we can see this number is increased by 2. 1423 had increased by 2, so remainder is also going to be increased by 2, that will be 7. Again 1425 is increased by 2, so this remainder is also increased by 2, that will be equals to 9. We need to divide it by 12. So now we have to see these were the three numbers, that is 1421, 1423 and 1425, and these are the respective numbers when divided by 12, that will be 5 into 7 into 9. So whatever the answer I'm going to get, that is the remainder by dividing these three numbers and or by dividing the product of these remainder of these three numbers, is going to be same, because we have already learned that remainders are multiplicative in nature. So what I'm going to do here, remain this 5 as it is, make this 7 into 9 to be as 63 divided by 12. So when you'll divide 5 by 12, positive remainder will be 5 only, and when you'll divide 63 by 12, positive remainder will be 3. Again need to be divided by 12. Now 5 into 3 will be equals to 15, need to be divided by 12. So when 15 divided by 12, positive remainder is going to be 3. And 3 further can't be divisible by 12 because this is going to be the final remainder. So we have to keep dividing it till the time we are getting the number which is smaller than the divisor. Why so? Because the remainder is always going to be smaller than the divisor. So this is the logic, this is the question which is helpful to obtain the logic of that remainders are additive, subtractive or multiplicative in nature. Now coming directly to the question now. It says 4 to the power 61 plus 4 to the power 62 plus 4 to the power 63 plus 4 to the power 64. What will be the remainder? Or you may say the question says, among the listed option, that is 3, 11, 13 and 17, which of the following is going to perfectly divide this given expression? Okay, now let's say in order to deal with this question, I'm going to simplify it a bit. So I'm writing this to be as 4 to the power 61 plus 4 to the power 1 dot 4 to the power 61 plus 4 to the power 2 dot 4 to the power 61 plus 4 to the power 3 dot 4 to the power 61. This is 4 to the power 61. So taking this 4 to the power 61 common, this can be written as like 1 plus 4 square is 16 plus 4 cube is 64. Summing them up can be written as like 4 to the power 61 into 85. Now this form and this form both are very same. Now in order to solve this question, we have to see among the listed option, in order to solve this question easily, we have to see among the listed option which of the following can give me the remainder to be as 0. Because understand this thing, if A into B need to be divided by, let's say, 3, and if A is giving the remainder to be as 0 and B is giving the remainder to be as 1, then overall remainder is going to be 0. Why so? Because remainders are multiplicative in nature. So we can see one of the number, that is 17, is perfectly dividing 85, so that can be the probable option. So let's solve this. This is will come 4 to the power 61 into 85, need to be divided by 17. This thing can be written as like 4 into 4 to the power 60 into 85 divided by 17. So this will become 4 into 16 to the power 30 into 85 divided by 17. So now we can see when 4 divided by 17, positive remainder will be 4. When 16 divided by 17, the positive remainder will be 16 only, but negative remainder can be written as like minus 1 to the power 30 into when 85 divided by 17, remainder will be 0. So finally we can see we need not to solve these parts because 0 into anything will be entirely 0. So remainder will be 0. So in this case the correct answer is going to be option number D, that is 17.